بسم الله الرحمن الرحيم رب زدني علما.
Now, if you just try to summarize these things, most of this information you will see in the show IP BGP table. Now, this is your BGP forwarding table. Now, this table will have a lot of information. Especially, it includes all the list of networks which are being advertised or learned through BGP. And then it also have the next hop attribute. And if you remember, I said whenever you see the next hop 000 means these are locally advertised routes in BGP. And whenever you see the next hop any other IP, which means it is receiving from this neighbor. So again, the BGP is a well-known and the mandatory attribute. Sorry, the BGP next hop and AS path. Now here you'll find AS path information. So whenever you see just I or just question mark, that represents the origin code, which means these routes are coming from the same AS. So if you're receiving any routes from the same AS, then you will have like this. But if you are receiving the routes from other AS, then you will have the output like this. You will see the list of AS numbers listed over there. But whereas from the same AS, you don't see that. So these routes are coming from a different autonomous system, originating from 64,998, 64,999 before it comes to my autonomous system number. And if you don't see any AS information, just you see this, means you need to understand these routes are learned from the same autonomous system number. And again, remember we discussed the origin code. Question mark represents the routes redistributed, and I represents the routes which are advertised in BGP. So those origin codes you will see. So additionally, you will have metric, local preference, weight attributes. So these are again the additional advanced attributes. We'll be seeing some of these attributes in the next topics. And these attributes are used to change the best route. We'll see local preference weight attributes probably in our next topics, where we'll see how we can change or how we can manipulate the best routes, how we can do, how we can say that some traffic should go from service porter 1 and some traffic should go from service porter 2. We can do that. Path manipulations based on these attributes. And one more thing you will see, there is something called star. This star represents it's a valid route. So normally you will see star for all the routes, and any one of the route will have the greater than symbol. Now this greater than symbol represents the best route. Now what this means is, like here, let's say to reach this network, let's say there are two possible routes. So these are the two possible routes to reach 10.9997 network. You can either go via this next hop or this next hop. These are the two neighbors from where I'm learning the routes. But out of these two, which is the best route? So the best route will have this greater than symbol. So this is my best route, which is installed in the routing table. Anyway, we'll verify these things when we get into the lab in our next topics. But any one will have the greater than symbol, which indicates that it's a best route. So that's what it says. And again, there is something called R. R stands for RIF failure. Now, RIF failure is a kind of option, like the possibilities. Let's say you have your network, and I'm running some OSPF here. And let's say I'm advertising some 20 dot network, and this 20 dot network is advertised in OSPF. Now, this router is receiving this 20 dot network via OSPF. 20 dot network via OSPF. And also, let's say this route is also advertised in BGP. So, and then there is an IBGP neighborship between them. So this route is also learned through BGP. And in my case, it is IBGP. So, which means whenever a router receives the same network update from multiple routings, so it will check the AD value, and the default AD value for internal BGP is 200 and external BGP is 20. Because the BGP is not designed inside the AS. It is designed outside the AS. So that's the reason you will have a better AD value here, but internally you will have 200 because internally you prefer always OSPF or EHRP. So if you compare the AD values, which is better? So 20 via OSPF is better, which means this router, even though this route is learned through BGP, but it installs in the routing table based on OSPF. And we call this as a RIF failure. RIF failure is nothing but, it's not exactly a failure. It's just an explanation saying that even though this route is advertised in BGP, but it is not installed in the routing table because you have a better route, better AD value is present, so it is installing that route. So that's what the R indicates. It's not exactly a failure actually. It's just kind of, telling that BGP route is not installed, but instead of that, there is an alternate better routing protocol which is using or which is installed in that routing table. So typically that is what a RIF failure. So if you just wanted to compare this, what I can do is I can just quickly configure OSPF here. I'm just quickly doing some advertisements. And if I check on the router 2 now, if I say show IP BGP, now you will see, just take some time. Now you'll see this 10 network is shown as RIF failure. And if I say show BGP RIF failure, there's a command to verify that. You can see these two routes have RIF failures because there is a higher AD value which is installed. Because if you see the routing table, if I say show IP route, this 10 network, or if I say 10 network here, so this 10 network is installed in the routing table via OSPF, which is better than BGP. That's what it's better with a higher AD value. Okay, so these are some of the outputs we need to understand, some of the basic outputs, and because the BGP table is something we'll be seeing from here onwards. When we get into the path manipulations, we'll try to see BGP, and we need to understand the routes which are learned and some information on what you see here.